I thought to get today's thing going, I would go ahead and let's take a look at problem number 9 here. I got a question on problems 8 and 9. I figured out what the student did wrong. Oh, whoops, whoops, whoops. I want student view. Go to student view. Here we go, and it'll change. It'll change all the numbers too. So that'll be good. All right, so I'm on the student view. Let's look at problem number 9. Okay. Let's look at problem number 9, because I'm going to give you another assignment for chapter 18 also. It'll be part 2. Okay, so it's two spherical objects. They're separated by 1.68 times 10 to the negative 3 meters. So we can, this is a Newton's, Coulomb's law problem. Of course, the answer, now then, the objects are initially critically neutral. All right, so let's just get started. We draw the two problems. One of the things is I can't like put this up in the corner and draw the same. So I got two objects. They're separated by this distance r. And I'll probably just leave, and we've got Q1 and Q2. Okay? And so they're going to start gaining, what's going to happen is they're going to start gaining this negative charge here. That's going to be on the outside of the thing. So they're going to create a force. This is the force on 1 caused by 2 is going this way. And the force on 2 caused by 1 is going that way. All right. Now, we've got Coulomb's law, right? So we've got a Coulomb's law problem here. So we're going to say, all right, well, F is equal to, F1 on 2 is equal to K times, well, let's do 2 on 1 because then it'll be positive force and all that kind of stuff. But we do Q1, Q2 over the distance squared. But Q1 is equal to Q2. Q1 is equal to Q2. And we want to come up with N. How many? How many electrons? All right, so this is problem 9. I didn't write a lot over the break, so this is lecture 2. Okay, SP18Phys220Lec2Track1. Okay, so in case I drop it or something like that. All right, so we need to know how many. So what we're going to do is Q1 is equal to N times the charge of an electron. And then so we get the ratio of Q1 over QE, and that should do it for us, right? And they tell us what the newtons are, so we know it. This is known, and so I'll take F1 times r squared over K is equal to Q squared, okay? So the square root of F2 or 1 times r squared divided by K. Now the whole thing is in the square root is equal to Q. So you take the square root F21 times r squared divided by K. Now these are all big unwieldy numbers is equal to N times QE. You divide, and this should come out to be coulombs, and it does, because the force is in newtons. Okay, the force is in newtons, and K is meters squared per coulomb squared. Newtons meters squared per coulomb squared. So I've got meters squared up here per coulomb squared. So those all cancel. Coulomb squared, yeah. So everything works. Everything works. So that's good. And then just divide that by N. Now we've got some goofy numbers we got to put in there. But that's is equal to, so the square root of F21, this is the way your answers would look over K divided by N is equal to, or divided by Q, E is equal to N. That's the way our answers look in like Physics 460. We don't plug in numbers that often. All right. Well, let's just see if that works. Let's just see if that works. So let's run through the numbers. Let's go back and look at what the numbers say. So R, I'm going to write these down. R is equal to 1.68 times 10 to the negative 3 meters. And in F of 2 on 1, whoops, gosh dang it. Gotta turn this shit off. Turn this off. Yeah, there's all my, sorry about that. Well, let me turn this off too. Quit Outlook. There we go. All right, now that you all know my personal business, this is equal to 8.15 times 10 to the negative 21 newtons. Okay? All right. And K is equal to, let's go and go with 8.99 times 10 to the 9th newtons per meter squared per coulomb squared. All right. So there we go. So let's take 8.15 times 10 to the negative 21 times 1.68 times 10 to the negative 3 squared. Now notice what I did. I put two parentheses around that. Divided by, parentheses, 8.99 times 10 to the 9th. Okay? So I'm just going to go ahead and plug those numbers in. Oh, whoops. I'm not letting you see what I'm doing. There we go. Sorry about that. There's about 2 minutes of your life that you won't get back. Now this is equal to Q squared. I see no other way to do this problem but this way. All right, so I think we're doing it right. 8.15 second E to the negative 21. It's not a very strong force. Times, double parentheses, 1.68 second E to the negative 3 squared divided by 8.99 second E to the positive 9. Boom. And this equals Q squared then equals 2.55868,298. In other words, times 10 to the negative 36. That is a dinky number. And that makes sense to me because this is 10 to the negative 21. This is 10 to the negative 6. So that's 10 to the negative 27 minus 10 to the positive 9. So that'd be 10 to the negative 36. Now let's take the square root of that. Now notice what I'm doing with my calculator. I'm carrying all of those sig figs all the way through. So you do all the algebra and carry your sig figs all the way through. So then second square root, second answer, boom. All right. And I've got, I can tell you right now. Look, since I've carried it all the way through, I'm going to go ahead and round this up and say, well, this is 1.6 times 10 to the negative 18 coulombs. And this is equal to N times 1.6 times 10 to the negative 19 coulombs. What do I need to multiply this number by to get this number? 10. N equals 10. So that worked out. All right. Yay, team. You think I'm going to punch that in? You think I got the guts to do that? No units, because it's just a number. I'm going to say 10. Submit. Submit to me. I rule. All right, we'll go on to the electric fields next.